Hello and welcome back. So we've just finished a couple units on correlation analysis and regression analysis. We're going to go a step further and we're just going to dip our toes into multiple regression analysis. Now you can go super deep on this. That's not what this is for. We're just going to look at sort of what it does and a little bit of how to do it. Ready? All right. In regression analysis, one independent variable is used to predict a dependent variable. So when we were working with regression analysis, this is what we had. We had a strong correlation, we had a predictive equation, we had a standard error that was a bit high, and we had an R-squared that said that 58% of our data was explained. Okay, if the coefficient of determination tells us that 58% of sales can be explained by the number of calls a salesperson makes, what about the other 42%? Like, how do you explain that? Well, here's where we enter with multiple regression analysis. Because in reality, there are often many independent variables that could affect a given dependent variable. Multiple regression analysis allows for, well, multiple independent variables to be estimated against a dependent variable. Multiple regression formulas come in the form of that big thing. Wow, okay, what does that mean? Let me show you. It's basically an extended version of y equals mx plus b, where the independent variables are represented by x. The amount of change when a given x is changed by 1 unit is represented by m. That's like little individual slopes for each x. And b is the value when all independent variables have a value of 0, sort of like the y-intercept. Okay, so back to our story. We had number of calls predicting meals sold. Well, what if we add another variable? What if we add years of sales experience? Now before, when we were solving this, we were using the TI-83 and 84 calculator. But those calculators aren't strong enough to do multiple regression analysis. So I'm going to show you this cool website called stats.blue. Before I do, just a note, be careful which variables are x and y when you're doing your data input. Okay, let me show you how this works. So we plugged all our values in, and here's what we came up with. So let me break this down for you. At the very top is our regression equation. If you want a more general form of that, it would look like this, where calls is x1 and years is x2. This next section is the specifics on each independent variable, and the bottom section is specifics on the equation as a whole. And here you'll see your r-squared, and your standard error, and also an overall p-value. Okay, let's go look at the equation itself. The y-intercept for this equation is 10.94. So if a salesperson makes 0 calls and has 0 years of experience, he'll sell 10.94 meals. Well, that doesn't really make any sense until you look at the coefficient of determination, which tells us that only 84% of the data is being explained. We are still missing 16%. These numbers here tell us the coefficients for the independent variables. So 1.07 goes with calls, 1.16 goes for years. And then there's a p-value for each variable. In this case, each is below 0.05, which is really good. Smaller p-values are more significant. And we're going to do a little bit more about that in the next lesson. With our R-squared, we know that 84% of the data is explained, and that's an improvement because before we included years of experience, our R-squared was only 0.58. Our typical data point, our standard error, is 6.51 meals from the regression line, which is also an improvement from the 9.9 before we included years of experience. So let's take this for a test drive. How many meals will you sell if you make 33 calls and have 17 years of experience? Here's our regression equation. We plug in 13 and 17, and you see you'll sell about 65.97 meals. Again, that's just a real quick introduction to multiple regression analysis. You can do so much with it, but let's just start here. Thanks for being here.